In the last part, I taught you about the nuclear process equation, but now I'm going to teach you about the properties of radiation and what is ionizing effect, and so on. If you haven't seen my last part, I recommend you watch that now before watching this video, or else it's going to be quite confusing for you guys. Anyways, let's continue. Now I'm talking about ionizing radiation. Now, both alpha and beta particles are fast-moving charged particles, and if they collide with or pass close to an atom, they may knock or drag electrons away from the atoms, and the resulting atoms are said to be ionized, and the process is called ionization. This is quite easy to understand, but if you don't understand, I'm going to explain in the next slide. Basically, after a lot of bumping or colliding with the atoms, the particle starts to lose kinetic energy because of Newton's third law, which I will remind you again. If a body collides with another body, that same body B, should I say, will push back not just the force but also the kinetic energy. Okay, so it will start to lose some kinetic energy and resulting in no longer having any ionizing effect. Okay, what you just read is basically a radiation particle, like an alpha particle, let's say, when it's passing through the atom because of the because it's just passing through, it will drag away the electrons. Okay, um, this is quite easy to understand. Basically, when a fast-moving object happens, it drags or pushes away the electrons away from the atom. That's how strong, or that's how high momentum the alpha particle give. So what I'm saying here is the higher momentum of the radiation particle, the more higher the ionizing strength. Okay, and we know that momentum is equals to mass times velocity. So looking at this information here, and after doing the calculation, you should know that alpha particle has the strongest ionizing strength because it has a very high mass. Even though they're quite slow, but if you do the calculation, alpha particles should be higher. And in gamma ray, they have zero mass, so they produce zero momentum. Okay, so that's something you should know. Alpha particle has the strongest ionizing strength. So now let's take a look at the properties of radiation. Okay, one of the properties is the electric behavior. Now, if you haven't seen my other parts, you should know that alpha particle has a positive 2 charge on their symbol. They have a nucleon of 4 and a charge of positive 2. Positive 4 and positive 2. Okay, so you should know that positive will connect to the negative. So alpha particle, they will go down to the negative charge. I don't know if you can see here, but it says negative. So the alpha particle go to the negative because they're positive charge. Beta particle will go negative beta particle will go to the positive charge, okay, of the metal plate. Gamma ray has 0 charge, so it's not gonna go to positive or negative, so it's just gonna keep going straight. Now, beta particle, there's 2 types: a negative beta particle and a positive beta particle. So the positive beta particle will go down as well because they produce positrons. Positrons are positive electrons, so they will go down to the negative because they're positive. Okay. So since the alpha and beta particle are charged, they are attracted to the plate that have the opposite charge to their own. Beta particles are deflected. Are deflected more than alpha particles since their mass is much less. Gamma rays are undeflected since they are uncharged. Okay, I think that's something you should know. You can read all the information in just one table. Next, I want to talk about the Geiger-Müller tube. So the Geiger-Müller tube, or we can just say the GM tube, measures the count rate. A count rate measures the number of radiation particles. When when each count rate represents I messed it up. Each count rate represents a radiation photon, okay, or a single radiation particle. That's what a photon is. A photon is a single radiation particle. Okay. So a GM tube can measure the number of radiation. So if we put an alpha source here, and then we put paper in front of it, the GM tube is going to measure 0 because paper can stop alpha particles to go through. That is one of the properties of the radiation, you know. So alpha particle is going to get stopped by paper, but beta particle is going to stop by a few millimeters thickness of aluminum, and gamma ray few centimeter thickness of lead. So that's something you should know. Now, take a look at this graph here. During a nuclear process, the nucleon has decayed, and the count rate is going to look like this. Remember, the count rate measures the number of radiation particles. So, you can see here, the radiation particles are decreasing. Now, if you're thinking that the radiation particle is decreasing because of any reason, well, you can try to understand why, but radiation properties is because it's random and it's spontaneous. Okay, that's why the radiation particle decrease as time passes by. One of the properties of radiation is it's random and spontaneous. Spontaneous means it's not going to be affected by external factor like heat. Okay, it is impossible to predict the probability of decaying per unit time. So we can't predict the count rate in a specific time, okay, because it's always going to change. And this is one of the proof, the graph here, that radiation particles are random. So that's all the properties of radiation that you should know. Now, the syllabus mentioned you should show an understanding of the nature and the properties of the alpha, beta, and gamma radiation, and both negative beta and positive beta are included. But when I do the past paper or when I'm doing questions, I don't get questions referring to these properties. However, it will most likely that these properties will come up in a multiple choice question. So you do have to memorize them unless they give these properties in the data in the back of the paper. Sometimes they will give properties of mass, but you have to check on your own if they do give the data or not. If they don't, then you do have to memorize. You have to memorize them. But that's all for this video, and I'll see you in the next part.